right. Hello, everybody. Good morning, good evening, good afternoon, and welcome to Going Meta, Season 3, Episode 2. Today, the topic is going to be Supercharging Neo4j Aura agents with ontologies. And I'm very happy to have you here with me today. Jesus, how is it going? What's your day been like? What's your November so far? How's your November so far?
It has been great, super busy, and yeah, happy to be here too. This time on my own. I mean, we'll try to get more guests, but this time is just you and me, Alex. But yeah, super excited about this week because you know that we have this major event coming up, right? So I'm sure we're going to be talking about it, and we're both in it. Well, you more than me are going to be part of it, but we're both going to be involved.
Yeah. This tiny event that's happening on the 6th of November is called Nodes. We have
say the 6th of November, but it's in 48 hours, less than 48 hours, right?
Exactly. It's crazy, but it is actually less than 48 hours. We start early in the morning, European time zone, I think 3 a.m. or something. And then we continue all day long until the very I think the final first few hours in the morning European time zone again, on the 7th. So it's gonna be really good. We have 4 tracks. We have 140 plus sessions. So I think I mentioned this a bunch of times before, but really I'd like to invite you, and here I have a little bit more about it. So it would be great, obviously, to see you all join. It would be a miss if you don't register for it now. So you get all the sessions in recording. So if you don't, obviously 4 tracks in parallel, you won't be able to watch all the sessions. But if you want to watch them afterwards, or if something is you missed something, then definitely check that out. Have a look at the agenda, register for the event, and we have really full packed agenda. So yeah, it's a good one this year, and we have good sessions, good networking. It's always nice to see the graph community come together for this. So yeah, really looking forward to it, but it's also a little bit scary that it is now less than 48 hours away.
I can imagine, but I'm sure it's all going to be great.
Yeah, I'm sure of it. But yeah, today we are talking about Aura agents with ontologies. I think this is a feature we just added, at least the Aura agents bit we added only a few short weeks ago. It's a very new feature. It's still in early access, so I have to say this because sometimes it just breaks, as you know, with early access tools and features. So we'll try our best to make it work today and to see that the demo gods are with us. But it could also be that we have a little of an unfortunate event today. So we'll see. But we'll
exactly. After nearly 3 years, we've got to love these, right? Like living on the edge, right? And yes, try things and write code. So, of all days, today is probably one, up there where things can go wrong, because we're going to be trying it, and we're going to be writing code. So let's see, what can possibly go wrong.
Exactly, what can go wrong. As always, we'd like to keep it interactive. So if you have questions, any comments, any feedback, let us know. I'd like to specifically, I don't have it with me right now. I should have opened it up, but we've seen a couple of very, very nice comments in the past from viewers, which were obviously very, very nice from us. So I think here is one from Lars that says the combination of graph ontologies and AI makes more sense to me than ever, and shows that with LLMs the story of AI is not over yet. Interesting listener and regularly share the link to your channel here with complete conviction. So thank you very much for comments like these, and for participating, for letting us know that you appreciate what we do, and that's why we do it, actually, right? I mean, this is for you. So it's really nice to see that this is welcomed, and you enjoy what we're doing here. So we always like to hear from you.
Good. So I guess that's time for me to start sharing my screen. As always, I'm going to hopefully you can see it. So we're open couple of slides just to set the scene, but it's going to be very quick because we have loads and loads of code to write today, and we should get started ASAP. So, yeah. Topic is we're going to be experimenting with Aura agents, and we're going because we just love it here, right? We need to use ontologies to give it to go a bit meta, right? Because otherwise it would be too easy to just because that's the point, right? That's what Aura agents were created for. So the idea, and this is a post that Zach and Ed wrote a few weeks ago. The idea is exactly that: is give a very, very easy way to create agents. They say in minutes, and I invite you all to go read these posts because it will take you step by step through the construction. But yeah, it's this new surface where we can create tools and build an agent and test it on the spot, and then of course publish it, deploy it. But the idea is to make it really simple, and I wouldn't say no code because we're going to be writing code, but there's a number of things that you can do doing very little, and you're going to be able to connect some of the ideas that we're going to be implementing today to things that we've tried in the past in previous episodes. So this is what we're going to be doing. So sorry, I think you were going to say something, Alex.
No, exactly right. I mean, this is a great blog post. There is more resources available as well. I'll put them in chat as well as in the video description. We did a Road to Nodes workshop on Aura agents. So if you want to learn, more hands-on from start to finish, how to build these, what to do there, I'll share this link as well with you in the video description, so you can have a look at that. And obviously, it also will be part of Nodes in less than 48 hours.
Absolutely. Good. Yeah, and this is, an early access program, so we want everyone to go and test it and break it and report it back to us, but also to build cool things, and that's what we're going to be doing. So we're going to take what Zach and Ed did, and take, go a bit meta like we always do. I mean, the idea is pretty straightforward. So we're going to build a knowledge graph because that's, at the core of it. So you need to have a Neo4j database in order to then build through Aura this agent. But what we're going to do, like we've done in many other episodes, is okay, we're going to enrich a knowledge graph with an ontology, and the ontology is going to help us doing a number of smart things. And we've seen how ontologies can drive the behavior of certain agents. We've talked about that many, many times, and we invite you to go watch some of the episodes where we played with this idea. But what we're going to do then is, instead of go write a Python notebook like we've done many times, or build a Streamlit application, we're going to go to the Aura agent interface, to the API, and we're going to create an agent that works on the knowledge graph, but also that leverages the ontology. And we're going to see how we can use the ontology to drive the behavior of that agent and make it do some smart stuff. So that's basically the idea. Does that make sense, Alex?
No, sounds good.
Cool. And as always, well, I'm going to be using one of our favorite data sets that we've used many times, and it will be very familiar the moment I show it. I think it's from season 1, or maybe 2, but it's a small subset of the catalog of the Tate Modern, yep. Right? So you probably remember these ones. So we basically there's fragments of it are publicly available, and I think we also took some bits from just scraping the website. But basically, we built a pretty simple graph like the one you see there. I don't know if it's readable there, but we're going to see it in real, live in Neo4j in Aura in a minute. But basically, we took some items from the artworks from the catalog, and we extracted information about the artwork itself, some characteristics about it, like the text description, the dimensions, the materials that were used. All these is available through the public websites, and we create also notes for the author of the artwork. That's also publicly available. And finally, and that's interesting because they seem to have removed that from the public website, but because we had the data set from season 1, I'm reusing it, and it's pretty cool because they basically annotated every artwork with some kind of I think subjects, right? So, for example, this artwork represents a figure or some dynamism. It's pretty interesting because it's a rich description that actually is very, very cool to represent as a graph, because it will capture things like, for example, a strong overlap between two artworks, right? For example, these two artworks created by different artists happen to have in common the fact that they use geometric shapes, right? The abstract paintings, and this is a good example of it. So that's the graph. It's pretty straightforward, and for details on how we constructed and everything, I invite you all to go to. I'll find the link to the episode. I can't remember exactly what it was, but we'll make it public. And what we're going to do today is we're going to be a bit more quick on the creation. Let me actually get started and jump onto Aura. So this is my Aura database. I just created an empty one, as you can see. I'm going to maybe go a bit wider. Well, you tell me, Alex, if it's readable or if I should make it a bit bigger. But the idea here,
a little bit maybe, but I think this is the
bigger?
wider is better, slightly, just a little bit.
Okay, so I can try to go a bit like that.
Yeah, no, I think that's good. Yeah.
Okay.
Yeah, let us know in chat if you think this is still too small, but I think
okay,
from my point of view, it looks good. Yeah.
So as always, the code will be available, but here I'm literally doing a copy paste. We just reading a bunch of JSON files. Again, the code is available, and it's the same we use in that series, in that episode. So don't worry too much. It should be relatively straightforward to create. We have a JSON file with the collection information, with the artworks. Then we have the artists, etc., etc. So this is a very straightforward input that we're going to run. It creates a couple of index, and it should be done very quickly, and we immediately see something like what we had on the slide a minute ago. So if I do a match on I don't know, let's say an artist, for example, well, let's do it because I don't know exactly how it's written. So if we have the artist where the a.name contains Warhol. So let's return the subgraph that's formed by these artists that I hope will be Andy Warhol, connected to the artworks that he's related to. Well, let's do something simple like that. Property key does not exist. What did I do? A.name. Oh, subgraph. I didn't. A.name is probably author name or something like that. No, artist name. What's the? Let's have a look.
Maybe. Yeah, let's see.
Click on that. Artist name. Yeah.
Artist name. Yeah.
Okay, so let's get the artist name, and now we get Andy Warhol with the name and some of the works that we happen to have in this catalog. And what's interesting is that if you expand these artworks, well, they are annotated with all these. We call them subjects, right? So this Statue of Liberty, where we have loads of information about, like the catalog entry, the credit, etc., the description. We also have these annotations, and it tells us that it's, it refers to society, to places, to freedom, because it's Statue of Liberty, and this is the kind of thing, the kind of graph that we've built, right? And this is the graph we're going to be working on now. The kind of agent that I want to build on this graph, and I'm going to have to enrich this graph a little bit. So, but before we get into that, I'm going to try to describe what I want to build. So I'm going to, I think we did something similar in that episode. Remember how we said Alex is going to visit the Tate Modern, and I want to give some ideas of what I'm interested in. I like, for example, Andy Warhol, or I like artist X, Y, or Z, and I like geometric shapes, or I like buildings, and it would kind of take all these things and give you a recommendation of maybe what you should look at. So it would be something like that, a kind of a recommendation sort of, or an art gallery assistant, I think we called it, right?
Yeah, I think that's what we did. Yeah,
right. So now we could, and I think we've been through that several times, and as in we can sort of hard code in a way, like in capture, when I give you an artist, you have to navigate to the artworks, to the styles, or to the subjects, or I can try to make something generic. And that's what I want to do, because I want my agent to be generic, but to be informed by the information in my ontology. So my agent is going to do something similar to this. So I'm going to give it some interests, let's call it, and that can come from me typing it, or maybe the agent picking that up from the memory or from history or from whatever they know about me. And we're going to pick that and do an initial semantic search over the graph. And if we want to do semantic search, we're going to have to create a vector index. So we're going to do that now, because at the moment we don't have vectors. We have to create them, and we're going to have to put them in an index. So I'm going to start with an initial, I wouldn't say global search, but I will decide what do I put in my vector index. And there I'm going to do this kind of similarity approximate search that we do in vectors, right? So whatever I type, I'm going to find something. It's a way of kind of throwing my net and jumping and landing somewhere that's related to what I'm looking for. But then what I want to do is I want to contextualize. But the problem is I don't know where I'm going to land. I might land on if I say that I'm interested in buildings, I might land in one of the subjects. If I say that I like Andy Warhol, I might land in an artist. If I say that I love this particular artwork, so I don't know what that's going to be. So I don't know how do I have to explore it. And I want my ontology to inform how to do that. But basically, my agent is going to have these three tools. A first one that does a kind of a similarity search through a vector index. The second one is understand where did I land, where I am. And then the third one is, given where I am, that's what I'm going to do to contextualize and provide information to the agent to ultimately give Alex a recommendation on what to do on his day at the Tate Modern, right? So that's the idea. And in order to do that, we're going to go to the, we need to enrich the graph, but basically we're going to go to the agents here. I've been playing with some tests, so I'm going to go and create a new agent and do it all here. But before I do that, let's enrich the graph a little bit, and that's what we're gonna be doing next. So we have this graph, and I was saying that I'm going to create a search space. I have my, let me find my graph enrichment thing. So, okay. So I'm going to put in a vector index things that I want to search over in an approximate way, right? Using this kind of semantic vector-based search. And because I mean, I could go and take all my artworks, and these could be thousands, hundreds of thousands, depending on, and it might be a large vector. And I don't want to spend too much time or rely too much on vector similarity. As you know, we like to take control of how we search and how we expand, because if we do it based on the graph exploration, that's going to give us stronger control, better explainability, and in general, much better accuracy. So what I'm going to do is control the fragments that I put in my vector search. And in this case, you know, it's a simple data set, so I'm going to probably overdo it. But in this step, what I do is select the bits in my graph that I want to potentially search over. And here I'm going to say, okay, I want to search over the subjects, and I want to search over the artists, right? So explicitly want to avoid going and doing a semantic search on the long descriptions that we have here, right? So I want to avoid sometimes creating large volumes of vectors might not be an ideal approach. So in this case, I'm going to avoid that by being selective. Oops, we don't want to do that, but let's bring it back. Let's bring back our Warhol. And what I'm going to do is I'm going to first add vectors, decide what bits to vectorize. And I'm going to start by vectorizing the subject. So if you remember, if I take any artwork, hopefully, there you go, they will have a number of subjects around it. And subjects have a single property, which is the text, right? So this artwork is about color, about Marilyn Monroe, about, you know, these are about an actor, an actress in this case. So it's about a body. So these are the topics that characterize or that describe these artwork, and will be shared by multiple other artworks. If I expand this, I'm probably going to have an explosion here, but there will be plenty of others, as expected. There you go. Plenty of other artworks that happen to have a depiction of people in them, right? So that's the idea. So what I'm going to be doing here is, okay, I iterate over the subjects and I'm going to extract the text, right? And I'm going to create, I want to make sure, that the embedding doesn't exist. So this is my way of kind of doing it iteratively. And I'm going to create batches of 500. So we have this method called GenAI vector encode batch that helps me, instead of doing a single request, batch the requests and make it more efficient. So I'm doing batches of 500. In this case, I'm using my the OpenAI embedding service, and I'm just attaching it to a new property that I'm going to call embedding. So if I run that, there you go. It should be relatively quick if things go well. There you go. We probably have to run it a few times because there's a few batches of subjects, but eventually, we'll get to a point where it fails because we've covered them all. And what we'll see now is that subjects have an additional property, which is the embedding that captures, in this case, it's a simple text, but it will give you the possibility. It's a simple kind of word, in this case, family, but now we have an embedding representation, and will help us going from, we've talked about this many times, from the text similarity to the semantic similarity, right? So this is the whole idea. So we've done it for subjects, perfect. And now we're going to do exactly the same for artists, right? And that's what we were saying before. Here, I'm being selective about the elements that I want to bring into my that I want to vectorize and then search over. So I'm going to take artist and take their name and do exactly the same. So I'm going to have to run it. I think in this case, there's not more than a few hundred artists, so that should be good. Okay, so now I'm done. And after that, both subjects and artists will have an embedding representation of the text information in them. We good? So we have vectorized the information that we want to search over. The next thing is we're going to put it in a vector index, because at the moment we've created the embeddings, but I want to put it in an index so I can do searches over. Now, at the moment in Neo4j, you can only create a vector index over a pair label property. So here, I'd love to combine in the vector, in the same search space, in the same vector index, the subjects and the artist, because I don't know what the kind of interests are gonna be provided. Are they going to be talking about artists? Are they going to be talking about subjects? I want the search to work regardless. So what I'm going to do is kind of a hack, which is, okay, I'm going to create an artificial tag, an artificial label, which is searchable. So any artist or subject, I'm going to tag it also as searchable, right? So this is a label that's only going to be used for me to be able to create a vector index over, right? So now I can say searchable is both the union of artists and subjects. And now I can create my vector index and saying that anything that's searchable will have a property called embedding. And the embeddings are of this nature, and I'm going to use the cosine similarity function. So far, it's just pretty straightforward. All these steps are going to be shared as always, but all I've done so far is vectorize some properties, defining a search space, and put it in a vector index. So we should be good to go from the search point of view, from the vector search point of view. And the next thing I'm going to do, like we described, is I'm going to overlay an ontology. And here, again, from the past, you might have seen we create these ontologies. Typically, we use often Protege or Web Protege. They're serialized in some of the RDF standards, OWL, and it will look something like this. This is the art ontology that we use in another episode. So basically, it will contain a formal schema description of what we have in our graph. And there will be things like, okay, there's classes, there's a notion of an artist, there's a notion of an artwork, there's a subject, and these are defined as classes. Classes is the terminology in OWL, but it's the equivalent of a label or a node type in Neo4j. And in the same way, we'll have things like relationships that are described in OWL as object properties. So has subject, if you remember, was the relationship that connected an artwork to a subject. We have created by as the relationship that connected the the artwork to the artist, and so on and so forth. And things were described as domain and range, as a source and target of the relationship. And we could annotate the ontology with additional information. Now, instead of, again, plenty of episodes, if you're interested in how we import ontologies, you can go to our rich and long catalog of episodes where we talk about that. But today, just to shortcut that process, what I've done is I've created an ontology using Cypher directly, and I think that's going to be very quick and very intuitive, because basically what we're doing here is we're creating classes for the different elements that we've talked. It's like an input of what we have here in this RDF OWL ontology. So if I run this, and again, the code is on its way to you, we're going to see something like this. We're going to have our classes connected to all the things. Let's actually make it simple. Let's get anything that connects to a class into a subgraph that we're going to call ontology, and return the ontology. Boom. It shouldn't take long, hopefully. There you go. Let's make this, can we make this full screen? Well, okay. I hope it's readable. Let's try to make sense of these. So we have the green nodes are our classes, as you can see. And this is kind of a subgraph that's sitting in the same database as the actual data. And we're going to see how we combine them together. So we have the class artwork, we have the class artist, and we have the class subject. And we saw that the created by relationship connects the artwork to the artist with the domain range, usual kind of representation. Has subject connects the artwork to the subject. And we have this kind of, because subjects are organized in a taxonomy, that's actually the Tate Modern Catalog creates like I think it's a three level deep taxonomy of concepts, right? There might be, like places, or places in England, and then London. So it's kind of a taxonomical hierarchical classification that's organized using the broader relationship, right? A subject would be connected. We can actually show an example of what that looks like. So if we take a subject, let's take a case where we have this broader relationship, I don't know, like 2 steps long. Taxonomy limit, let's limit it to a couple of them. I use tax meaning taxonomy. So there you go. Oh, it's using, let's take the readable name, which will be the text. Let's take one. Is there any one of length 3? Might be more interesting. There you go. So yeah, that's what we were saying before. So we have people, actions, postures, and motion, people sitting, people standing. So this is the kind of hierarchical organization that we see. And as you can see, subjects are related to other subjects through this sort of broader taxonomical relationship. And that's what we are capturing here when we say that the broader relationship connects domain and range is a subject. So yeah, as always, this is an ontology. It's a description, a formal description of the schema that we have in the graph. We also have what we call the attributes in Neo4j, but basically these are the properties. Again, the domain, an artwork will have things like a title, like a display caption, and this is the data type. Here, they're all strings, but you could have all the other data types. The artist has the artist ID, the artist name, and the subject has a text. So, well, there you go. That's the ontology. And what happens is that we've annotated these ontology with some additional elements. I mean, they are also standard in OWL. Things like, for example, what we call an identifying property in the RDF OWL world. That's something called inverse functional. What that means is that it's a primary key. So you won't have 2 subjects with the same text, right? So this is kind of a unique identifier. It's like a primary key. The same with an artwork. I know it's kind of a generalization. It works for our example. It might not be perfect, but we're saying that the title is a unique identifier. It's true that we can have multiple artworks with the same title, but for the sake of simplicity, we're taking that. And the same with the artist name. I know we should use probably a proper unique identifier, but we're saying that the artist name is an identifying property. So that's a way of annotating and indicating our agent later on how to identify and how to retrieve specific items of particular types. And similarly, when we have relationships, in some cases, as you can see, we've indicated that it's a contextualizing relationship. So this is my way of saying, okay, when you contextualize and you do the retrieval, follow that relationship, because that's important. If you have a subject, you might want to contextualize by bringing artworks, right? Or similarly, if you have an artist, contextualize by bringing the artist's artworks. But in this case, I don't want you to expand the broader relationship. I could, and it would be interesting. And I think in one of the examples we tried it, and we kind of navigated the taxonomy. But this is my way of kind of driving the behavior of the agent, as we're going to see, from the ontology. So that's, me taking control of how the contextualization happens by driving it from the ontology. I'll take a pause here before we go into the agent creation. Does that make sense so far, Alex? Any questions? Or
no, I think that makes a lot of sense. I think that's a great approach. And as always, I mean, when we talk to people, oftentimes this exactly what this exercise is something that is very recommended and is very helpful, because you get the structure, you get the schema sort of set up for your data, and then when you then import, especially unstructured data, you have this helpful scaffolding that you can attach your data to, and then it's much easier to follow that and to get that structure into your that context. Also, I think it's a great exercise of showcasing this again. I have a couple of questions, but they are, maybe we take them at the end and continue with with what we have planned for today and see how much time we have. The only question, I would like, maybe we can squeeze in, is from Joey, who already played around with the Aura agents and did some work and wanted to know if we have a plan for a dedicated MCP server.
Oh yeah,
officially supported Aura MCP server. Is that something we plan on doing?
Sure. Yeah, absolutely. So we already have an MCP server, and well, we touched on that last week when we looked. I mean, I don't know if he means like a cipher, and we have multiple servers, right? So we showed the modeling, the graph modeling server, if you remember, in the session with Alex, and we have also a cipher one and a memory one. But probably what he means is are these agents that we create through Aura going to be accessible through MCP, which is probably the direction of his question, and the answer is yes. I can't share because I just don't know it. What's the exact timeline? But this is something that's definitely in the roadmap. At the moment, you can expose. I don't think we're going to be touching on that today. I won't have time. You can expose the agents that you create through an HTTP endpoint, but the plan is to expose them as well as MCP and being able to integrate them directly with, like we did last week, like Claude Desktop or any other host application. So yeah, that's definitely in the plans.
Cool.
And
maybe one more here because it just fits me, from William. The ontology that you, Chris, created, did this come from Tate as OWL, or was this something we created specifically for this demo today?
This is something we created. So what you get, I mean, the thing is, the Tate, I think I was the collection artworks. There you go. So this is a relatively old, although I don't think it's changed substantially. You see, it's 11 years old. But what you have in this, where was it processed? So you have the subjects here, and you have the different levels. So what they publish, and they don't publish it in a RDF-based format. They use JSON, but basically they enumerate all the level 0 kind of what we call subjects. So, for example, this is group, movement, architecture, emotions, concepts. So these kind of things that we're seeing. Then we have level 1. You have the next level of subjects with a reference to the parent element. So they kind of build this taxonomy, but they use their own proprietary, simple JSON. It's just a 3-level deep taxonomy. So they publish it like this. So this is what they published. The ontology is something that we created and that we used in this episode a few months ago. So where we describe the different classes or node types and the relationships, the properties. And again, I'm sure we can send him some links to episodes where we create the ontology with Protege or with any other environment.
Exactly. I just wanted to say, right, I mean, check out the backlog of the Going Meta episodes. You'll find examples where we did either create our own ontologies or where we used in existing ontologies. So the best way to look at these is exactly this page, which is in the video description, where you find all the previous episodes, and then you can see them where we had
and if you search for ontologies, you will find plenty of episodes where they might even be references to maybe to Protege. Exactly. So we mentioned that places where we use these tools to do different things, like versioning in this case, building semantic data application, and so on and so forth. So when in some cases we've used pre-existing ontologies, maybe the question goes also in that direction, but sometimes we just create our own and use standard tools for that.
Cool. All right, let's go to the agents.
Let's do that, because it's gonna requires some time. So let's go to agents. And I'm going to go step by step. So the interface looks something like that. So I'm going to be doing a bit of copy pasting so that I don't make mistakes. But basically, I'm going to be creating sort of our recommendations. Let's call the agent Onto agent Going Meta. It's 3 today, right? So no, it's 2. Going Meta 2, episode 3. And we can provide a description. Maybe this is something I've used in the past, ontology-driven agent. And we're going to give a prompt instructions. And this is, the problem is if I paste it there, it's not going to be super readable, but let's try. So maybe I can expand it a little bit. So this is the steps that I described before. So I'm going to say your recommendation. This is basically the prompt that we're providing, right? So your recommendation agent that gives recommendations based on someone's interest, and you operate as follows. It's 4 steps. So first, we start with similarity search tool. We're going to create that in a moment. That and if there's multiple interests expressed in the input, we'll run separate searches for each one of them, right? So that might return, we don't know. I mean, it might be subjects, it might be artworks, it might be artists. So whatever I've put in my search space. The second one is for each result, I'm going to go query the ontology and see, okay, what is that, and how do I get more information about it? Right, so that's because I don't know upfront what that's going to be. I'm going to go and explore the ontology to understand what that is and how can I contextualize it. And the third step is actually doing the contextualization. And for that, again, I'm going to be using the ontology to understand how I can navigate out of the item, whatever it is, and provide the extra information in the form of another tool. So basically, each one of these are going to be tools. And ultimately, I tell the agent to combine the return results by the tools and build a final response. And I said that present it in the form of a personalized email. I could have put it in whatever other way, but that's what I've come up with, right? So this is our agent, and we need to tell which instance to use, and this is the one we're working on. So it's Going Meta Season 3, Episode 2. So at the moment, there's a one-to-one match between agent and Neo4j graph. In the future, we're going to be able to point at multiple ones, but now I have to do this kind of selection of one. Initially, it's an internal one. We'll be able to publish it, and that's the bit where I'm not going to be able to go in details today, but you can expose it publicly and access it via HTTP.
Yeah,
and yeah, so we're ready to start creating tools, and we need these three basic tools, right? So these are the three types of tools that we can create. So we can create a text to cipher generic one, which we're not going to be using today, but basically that would take a question and try to translate it and generate a cipher query on the fly. We can do semantic similarity search, and we can create cipher templates. So these are the two that we're going to be using. The first one is going to be a semantic similarity search, and let's call it, I don't know, something like initial semantic search. As you see, I've typed that in the past, so that's handy. The second one,
didn't complete the name.
Initial, it's not super important. Well, sometimes it's important because all these are this description of the tools are important, because ultimately remember how an agent behaves. An agent analyzes the task, it takes the prompt, and it will look at the available tools, right, and use them to try and get the best results. So this is the initial semantic search. It's I don't think we can provide them. Let's call it, I don't know. This is, I don't know what to provide as a description. We might even leave it empty or replicate that, or let's call it so we have created, this is important, so we have to match the service that we use to create the embeddings. Remember, the vectors were created using the OpenAI service, and in particular this ADA002 model. So that's that needs to match the one that we use for the creation, and then we're going to have to refer to the index that we created, and I believe we called it global search. Let's double check now in a moment, and maybe, I don't know, we're going to limit the search to the top three, something like that. We can decide. I mean, in the interest of efficiency, we're going to do it quick here. So okay, so I've created my first tool, right? So, and we can enable disable. That's there. So that's my first the first one. The second one that I'm going to create is a cipher template. And remember that in this step, what we're going to be doing is step 2 gets the output of the first one, and they're going to be nodes, because remember how vectors are stored in Neo4j as properties of nodes, and then we put them in an index. Now, when we do a semantic similarity search, we're going to return the top 3, in this case, best matches, and we're going to do reference those and say, well, this vector is actually a property of this subject, or this vector is a property of this artist. So I'm going to get nodes as output, but I don't know of which type, because I've intentionally done it generic to give the flexibility to this initial search. Now, here, what I'm going to, the way I'm going to call this is, the name is a query. We're querying the ontology for identifying properties, the identifying property for a given label, because I don't know which one, and you're going to get it in a minute what I mean by that. So I need to understand, okay, what you gave me is what? I look at it, I introspect it in the ontology, and I say, well, this has a labeled artist. Okay, how do I get more information about artists? Because I'm going to run a separate query. Remember that each tools are run independently, right? My agent is going to run tools in sequence and then chain them as it decides to. So this is an artist, and artists are identified by their name, as we define in the ontology. Remember how we said that it was not a great idea, but that's what ontology says, right? So basically, this is what this tool gives us. So given an object return, so I'm going to basically describe it here. So given a label that passed as parameters, so what I got is an artist. So how do I identify artists? Because the artist can come, or the object can come with a multiple collection of properties. How do I make sure that I get it back? So that's what this tool does, and we're going to do it with a simple query, and I'm going to put it here, but we're going to test it also in Aura. Is a query that takes a parameter. The parameter is the label. So the label is of type string, is node type /label. So that's what it does. So given a label, I'm going to find what are the identifying properties of that. Here we go. So if I save this,
and then maybe to add here, important bit to know or to keep in mind is the description here is somewhat important, because the tool or the agent rather doesn't know exactly what's going on. So the more verbose, I would say, you are in the description, the clearer it's going to be for the agent to know which tool to pick, and then to run these accordingly. So if you just type something that is not very clear,
correct,
it's also very difficult to identify what tools to use in what step.
Very good point. So basically what this query just wanted to show what it does, because this is where we're going a bit meta, right? So we are effectively, we're saying, okay, I want to understand how do I identify, for example, things of type artist, because ultimately what I'm going to be passing there as label is a value, and it's going to be, so if it's an artist, what do I use as an identifying property? So I'm going to go query my ontology, because remember, in my ontology, we have things like the artist name, which is the identifying property for an artist. So I'm looking exactly for that. This is what my ontology tells me, and that's what I'm querying here. And once I find it, once I find what this identifying property is, and it happens to be called artist name, I'm going to go and, well, in this case, return it. So if I run this, this is going to tell me the property in question is artist name, and it's a string, is the data type. In this case, I'm not complicating things with different data types. Everything's a string, but basically that's what this step does. So it's giving me the information in the ontology on how I should go and contextualize my the information that I got from the vector search. And finally, I'm going to add a third tool, which is another Cypher template. And this is the one that effectively does the contextualization, right? So we're going to call it something like contextualize the results of the semantic search. And in this case, now I know, how to identify objects of a given type. And I'm going to describe it. So it's a tool to be applied always to the results of the semantic search. And here I need you to give me the node type, the identifying property, the name, and the value, and a data type, although here I'm not going to use it. And it will return a contextualized response, not just the object that was returned by the vector search, but a contextualized version of it. And the query, and we're going to test it in a minute again now, looks something like this. And we're going, again, a bit meta here. You see that this is using a number of properties, parameters. The first one is label, all being string. So this is the, we can say that's the a node type or label. Another parameter that we're passing is the key and the value. So the key is type of string, and it's a property name. The value is a property value. A property value. And finally, well, there's the data type, but we're not using it. So I could, let's put it as a parameter, although we're not using it, because the previous tool returns it. Particular property. So yeah,
but that would be a data type. Sorry,
whether it's a string, whether it's a boolean, whether it's a numeric one. But yeah, we're not using it. But as you saw, the previous tool did return the data type. So I'll pass it to the next tool, but it's not actually being used. So, and what does this query do? Because this is it complicates things a little bit. But let's save this before. Here we go. So we have the three tools here, and we can test it again. So if we say, okay, like we did before, so if I'm looking for how do I contextualize, for example, artist. If if I get an artist, what I'm doing is, okay, find all the contextualizing relationships in the ontology that are connected to the artist, and they can be connected either domain or range. So that means they can be incoming or outgoing relationships. And so what we are doing here is then, okay, once we know that, we're going to be navigating, and we're leveraging the dynamic cipher features. So I'm going to look for artists, and I'm going to be looking for navigating the relationships that I've returned from exploring the ontology. So this is the dynamic definition of this relationship type that comes from actually the name of this definition in the ontology. And ultimately here, I'm looking for, in this case, probably something like what was it? The artist name. So all these will happen dynamically, and I will be looking at what was it? Andy Warhol. Did we? How was it described? Well, let's look at anyone. It doesn't really matter. Let's pick one that has at least some artworks. And if I look at this one, Hornell Edward Atkinson, for example, why not? So there you go. Oops, double quotes. So if I made no mistakes, this should return in the form of a table, because I'm flattening it. So, but basically it's returning me the artist and the related thing. I don't know what it's going to be, but in this case, it's because it's an artist, it's going to be an artwork. And I complicate things a little bit. You might be seeing here that I'm removing a key. It's because I'm removing the embedding. When I return the results, I don't want to stream back the whole chunk of, because I'm getting all the properties, all the properties of the artist. But I have the labels, I have the ID, the name, but I don't want the embedding because it's useless for the text generation.
Exactly.
So that's where I'm filtering it out here to make it a bit more compact. Anyway, so we have the three tools there, and we have the definition of the agent. So we're in a position to start testing it. So why don't we say something? I like Andy Warhol. And I'm going to make a mistake in the name. Why not? Just to prove that it's not dependent on the perfect spelling, because it's doing an approximate search.
Exactly.
Like Andy Warhol, and I don't know, and geometric shapes. Think of these as maybe these are statements that are persisted in the memory, in the agentic memory. So something that, as you know, as you interact with an agent, you can persist that in a memory, and we haven't. That's something that we'll maybe cover in another episode, because the whole subject of agentic memory is super interesting. But imagine you have bits of memories. Like I know that Alex likes Andy Warhol, and I know that Alex likes pictures that with geometric shapes, or I don't know, with buildings or whatever. But anyway, I'm going to put that, and let's see how the agent behaves, and let's cross our fingers, because that's now where it's going to be probably following more or less the guidance that I'm given it there in the prompt. This is the testing environment. Once I'm happy, I'll save it and expose it, and we can test it again. But roughly, that's as you can see, it's been this is a really sort of meta type of agent. And what's interesting is not so much the results, but let's look at the execution. So let's see what's happened. So this is the reasoning, and we get all the details. Is it readable? Shall I make it a bit bigger?
I just wanted to say maybe zoom in one click. Yeah, I think that's better.
There we go. So it says, the user has expressed interest in Andy Warhol and geometric shapes, right? So to provide recommendations, I need to gather information about these interests. And he says, okay, we start with the initial search tool, which is great, because that's what we told it. So he went and picked the initial search, and he went with. I told it to do separately 2 different searches, but still, it went with one. That's something that we might fine tune with the prompt. But anyway, let's see what that did that return. Well, unsurprisingly, Andy Warhol. It was returned as a match. There's twice. I don't know why. Then Picasso, maybe it's similar to semantically close to Andy Warhol in this catalog, but we sort of A negative thing is that because probably it run it in a single search, we missed the geometric shapes element. But let's continue. So we got this first initial, we limited it to 3. So we have these 3 elements. And the next thing we're going to do is, next step is to find the identifying labels for these elements. So I'm getting Picasso and an artist ID and the name and the labels. So what do I do with it? And I go and ask the ontology, and for that I'm running the query ontology for identifying property and label, which is the second tool, and I'm passing something that is a subject. Okay, well, if I search for a subject, I'm going to get the property, identifying property of a subject is the text, which is correct, right? If you look at that's what the ontology says, but also if we look at subjects, you see that the property is called text, right? So this is adult, or actions, expressive, and so on and so forth. So that's the ontology is doing its job. It's kind of guiding the agent in the right direction. So okay, now that I know that this is what I'm supposed to use, I'm going to and it's going to do it as well for artist, because it returned objects of type artist and subject. So it did it for both. And for artist, it got, well, for this is artist name and it's type string. So similarly, it did a good job, because for artists, as we've seen before, the property is artist name and it's of type string. So great stuff so far. And well, next step is, okay, I now know how to what these things are. It's returning subjects and artists. So I need to go and contextualize. So in order to contextualize, I'm going to call the contextualize results. And this is the third tool that I created. And I'm passing, all the elements that I found. So it's, the label is subject. It's interesting because now I'm thinking that Andy Warhol appears both as a subject, and as an artist. So maybe there is a subject. I mean, I'm thinking if Andy Warhol is
maybe
the
a
subject
self-portrait or something,
so
could be like that.
Yeah, that would be interesting. I don't know. Let's do just a sec. And I know we're going kind of over time, but I'm curious about this one. So if we have a subject where s.text contains Warhol. Yeah, there's a subject, and now the question is there? There's an artwork. So there's an artwork
from a different artist. You see, from Mapplethorpe.
There you go. So someone painted him. There you go. So these artists painted him. So he's the. So we can, if we're very curious, we can copy this and go and see what that looks like. But it looks like it's a depiction of him, as we were suspecting. So there you go. So we'll leave that there.
It's a
so
picture.
It's a
photography. Yeah.
Exactly. So it makes sense. So we got so the agent is clever. So it's found both Warhol as a subject, but also as an artist. And well, we retrieve in this case how to get the information about these elements, and then we contextualize. So subject Warhol is a subject. And what we do is, well, it explored and it realized that from a subject you have to go to the artwork. So we get the artworks that relates to the subject, and probably is this painting.
Yeah, that's what we found
by Mapplethorpe. So that would be the one. But then also, if we contextualize the artist Andy Warhol, we'll get the actual works by Andy Warhol. There you go. So it kind of depending on what you get. It contextualizes one way or the other. And that's where the clever bit is, because the ontology is effectively driving that behavior. And ultimately, this is the explanation and all the details exchanged, but ultimately it produces a summary that's that's perfectly grounded on the information in our graph. And we've had full control of every step in the process, right? So every bit of information produced here, which is ultimately what we want to do when we ground an LLM or create an agent with a knowledge graph, is that it gives us the explainability that we've seen in every step of the reasoning. So here we go. So these are the works. But and finally, interestingly, Andy Warhol himself was the subject of art. Exactly what we said. So fantastic. It was not intentional. I hadn't tested this one, but it couldn't have been better. There you go. There you go. Well, that's the example. So I think we're going to stop here because it's taken longer than I expect. But it's good that if we're happy with the results, now we would save it, and now we have the agent ready to test here again. But yeah, that was the objective of today's session. I know it was pretty dense, but I'm glad we covered the whole thing. All the code is going to be available for you to test, but and reproduce at home. But there you go. That was the plan, and we made it just in time.
Cool. Yeah. Thank you very much, Jesus. Yeah, that was very interesting. I think it's a lot of fun to play with the Aura agents. I think it's an invite to all of you, or maybe I should put it here. If you are interested in that, have a look at it. It's free. You can use it with the Aura free version as well. So it's really easy to get started, and have some fun with it. If you want to know, like I said in the beginning, more about the Aura agents, how they work, and how to build them in more in-depth view, then I linked to the in the video description on YouTube. You'll find the link to the Aura agents training as part of Road to Nodes that we did a couple of weeks ago. So that's another point I would recommend. And obviously, Aura agents will be part of Nodes itself in 2 days' time. So if you're interested in that, check out the Nodes agenda and look for Aura agents. You'll find a session there that covers it in Nodes 2025. I've seen we had a couple of questions, and as we are over time, I think we are probably not quite able to answer those. But yeah, sorry for that. We'll
take this offline. We'll get back to you, but yeah, let's. I would say, remember that what we did today is we created an agent that was working not only on the data but also on the sort of metadata in a way that the ontology captured, and that's what we didn't get to that point, but by changing the elements in the ontology, I can modify the behavior of the agent, because remember how we specified which were the contextualizing relationships. I can basically tune how my the information retrieved by the tools is actually contextualized in each case, and I wouldn't need to change my agent. That was the powerful thing. The agent is generic enough to work driven by whatever is in the ontology. But yeah, we'll get more these questions answered, and we'll put the code so that anyone can give it a try.
Exactly. Put that up. The link is also in the video description, as always, on our GitHub repo for Going Meta. Thank you very much for watching. Thank you for participating. Sorry we couldn't answer all your questions. Again, if you have questions beyond that, always the YouTube comments is the place to put them there. And yeah, with that, I see you on Thursday, I hope, everybody. Until then, thank you very much for watching today. Thank you, Jesus. Again, great demo, great showcase today. And yeah, see you soon. Take care, everybody.
Thank you. Thank you. Bye-bye.
Bye.